Good morning. Today I am going to teach you one of the important construction in the triangle. In the triangle chapter, I am going to teach you one important construction. So, you have to divide the line into a given ratio. You have to divide a line into a given ratio. For example, you take a line, let us say AB, and this AB you have to divide in a particular, you have to find out a P in such a way that it is AP is to BP is equal to 2:3. That means you have to divide a line segment in a given ratio. Otherwise, locate a point on AB such that P divides AB in 2:3 ratio. This is the construction, a very important construction. Okay. So, for this you have to use basic proportionality theorem. Now, let us take a line segment, draw a line segment. First one, let me use draw a line segment. I have drawn okay. So, this is let me write A, B. So, A is a point and B is a point. Find P such that P divides AB in the ratio 2:3. So, if you draw a rough figure, I told you AB is the thing, you have to find out a P such that this is 2 and this is 3. This is you have to do the construction. Okay. So, now let us do it. Now, our target is to do this one. Now, let us take, okay, and you take a scale and draw from AB any line with an angle. Okay. So, some angle you have to draw, any angle. That means this is a line. This line you can draw from B also, from A also. You can have upside also, downside also, anywhere. Okay. Now, our target is to find out P on 2:3. So, total 5 parts. You take a compass, okay, and keep the needle keep the needle on this and one arc, okay. Again keep the needle on this, again draw one more arc, again keep the needle on the latest one more arc, total one more arc, again. So 1, 2, 3, 4 arcs I got, and I should get total 5 arc. Okay, I will keep this side. So then let us say this is this part is A1 and this part is A2 and this part is A3 and this part is A4 and this is A5. We got equal parts on this ray AX. Let us name it AX. Okay. So now you join A5 and B. Take scale. Okay. Keep at A5 and join so that means A5 and B we have joined it. Okay. So now we have got a triangle A5, B, right? So now already A5 is divided into 5 parts. Okay, A1 is one part, A1, A2 is one more part, A2, A3 is one more part, like that. So now you have to draw a parallel line. You can draw a parallel line through A4, through A3, through A2 and through A1 also. So then what happened if you draw a parallel line like this? This parallel line divides AB in the same ratio. That means this ratio is 3/2 and this is also will become 3/2 as per the basic proportionality theorem. So now our thing is you have to draw a parallel line through A2 and this parallel line meet AB at P. So this is 2 parts and this is 3 parts. So that means AA5 is 2/3. Therefore AP and BP is also 2/3. So then P divides AB in the ratio 2:3. A very, very important construction, and all have to do this construction. Okay. So now with this construction part is over. Same question is there. P divides externally also. That means P lies outside. So that also you can do by using a textbook method. So let me go to another question. Okay, let me go to another question. I will just go to exercise. You can open your exercise and 6.2 exercise. 6.2 exercise, question number 1, a very, very important question, 1 mark question, directly application of basic proportionality theorem. That means he has given a triangle. I am not drawing it properly. ABC is a triangle, DE is parallel. So then this is 1.5 centimeters, this is 3 centimeters, this is 1 centimeter, and this is how much? So what he asked? He asked EC question mark AD in 2. So that means this is you have to find out. As per the basic proportionality theorem, because these two are parallel, so AD by BD is equal to AE by CE. So AD by BD is nothing but 1.5 by 3 is equal to 1 by, let us say, CE. Cross multiply it. So 1.5 into CE is equal to 3. So CE is equal to 3 by 1.5. So how many times it will go? 2 times it will go. So this is a 2. A very, very important application of basic proportionality theorem. Hi, hello. Okay. So now one more question is there in first question, first bit, one more bit is there in the first bit, you can do by yourself. Okay. So now let me go to second question. E and F are the points on PQ, and in this also figure is given, figure is not given. Figure is not given, you have to draw a figure. So now PQR is the triangle. He has given very clearly PQR is the triangle. E and F are the points on PQ and PR respectively, such that state whether EF is parallel to QR or not. So E is a point on PQ, let us say this is E, and let us say this is F. And a triangle chapter, this is a triangle chapter, I am teaching you 6.2 exercise. Okay. So we have to find out whether EF is parallel to QR or not, giving by seeing the data. I will just do first bit, remaining 2 bits you can do it. PE is equal to 3.9 centimeters, and EQ is equal to 3 centimeters, and PF is equal to 3.6 centimeters, and FR is equal to 2.4 centimeters. I did not write centimeters, so you can assume all the units are in the centimeters. So PE, let me write here, PE is equal to 3.9, and EQ is 3, and PF is 3.6, and FR 2.4. Now we have to identify, we have to check whether EF is parallel to QR or not. You just find out the ratio, PE by EQ. So 3.9 by 3, so 1.3. Okay. Now you find out other ratio, PF by FR, PF by FR. So this is how much? 3.6 by 2.4. So 3 table will go. So 1.2 by 0.8. Okay. Again 3 table will 4 table will go 0.3 by 0.2. So which is equal to 1.5. So that means PE by EQ is not equal to PF by FR. Therefore, EF is not parallel to QR. So if basic proportionality is true, then only you can have EF is parallel to QR. So this is also a very, very important question, direct question. Okay. So now two more bits are there, do in the same way. Now let us go to third question. Third question, question number 3, page number I can give you 84, 6.2 exercise. So for this they have given a figure. So let me draw the figure. Figure 6.18. I will draw the figure. AC is the base, ABC is a triangle above, ADC is a triangle below AC. This is ML and this is a LN. Now in this what is given, question number 3, what is given here? LM is parallel to CB and LN is parallel to CD. Let us indicate LM is parallel, indicate the parallel symbol, and LN is parallel, indicate 2 arrow marks because one single arrow mark already we have used here. So now you can apply basic proportionality theorem on the above triangle and below triangle also. Remember that you can apply basic proportionality theorem in a triangle if a line is parallel to one side. So this is a triangle, one line is parallel to one side. So you can apply basic proportionality theorem. So now prove that RTP AM by AB is equal to AN by AD. This is what is to be proved. So now I will keep the textbook aside and let me follow. So now if I apply basic proportionality theorem in this triangle, what you will get? AM by AB, I will write AB, corollary of basic proportionality theorem, which is equal to AL by AC. This is in this triangle basic corollary of basic proportionality theorem. In this also we will apply basic corollary of basic proportionality theorem. AL by AC is equal to AN by AD. This is the AN by AD I have taken, full side I have taken, that is why it is corollary. Okay. So then what happened in both the triangles? So this is first equation and this is second equation. In both the equations, AL by AC, AL by AC, one side is equal. So what that means, 1 is equal to 2. Therefore AM by AB is equal to AN by AD. A very, very simple question based on basic proportionality theorem. Now let me go to, there are 10 questions in this, I have done 3 questions. I will be doing 3 more questions or few more questions in my next class. For now I will pack up. Thank you. Have a nice day. Bye bye.